This is Math 2, 12.2 homework questions. That's Math 2, Unit 12, Lesson 2. You should have worksheet 2 in front of you. That's this one here. And I'm going to go over a few questions, starting off with number 1. Start off with some easy ones. Okay, X is an inscribed angle because it's not at the center, it's on the circle. So these are not equal. The arc is twice as big, or the angle is half of the arc. So since we know the arc, we're going to cut it in half. X equals half of the arc. That is 45. So this is 45 degrees. Okay. Now I know the angle and not the arc. I know the arc is twice as big, so X equals double 37. So you need to know when you're cutting in half and when you are doubling. If you know the arc, you're cutting in half. If you know the angle, you are doubling. If you think you might forget that, you can write it down. Okay, angle A. I'm looking for the angle, which means I'm going to cut this arc in half. The only problem is I don't know what this arc is. Unfortunately, they did not give that to me, but they gave me this is 75 and this is 120, and I know altogether that equals 360. So I'm going to do 125 plus 75, that is 200, and then I'm going to take 360 and subtract 200, and that gives me 160. All right, so angle A, what do? I'm going to call angle A X. How do I find X? I know the arc, so I'm going to cut it in half. X equals half of the 160. So X equals 80, so angle A is 80 degrees. All right, next one I'm going to do is number 8. I'm looking for arc CE. How do I find arc CE? Okay. Well, what do we know? I know that that inscribed angle is 25, and I know the arc is going to be twice as big. So if that's 25, this is 50. All right. Now, since that dot right there is the center of the circle, and that makes this the diameter, if this is the diameter, this here is a semicircle, which means the whole thing is 180. Can you see that? So I'm going to do 180 minus 50 to find what this remaining arc is, which is the arc I'm looking for, arc CE. 180 minus 50 is 130, so arc CE is 130. Okay, number 10 is can get a little confusing if you're not paying attention to where things are. Okay, what is X? How do I find X if they did not give me this arc at all? And they didn't give me any arcs at all. But they gave me that this angle, I'm going to cover this here. Can you see that this angle inscribes that arc? It intercepts that arc. So it's an inscribed angle because it intercepts that arc. So inscribed is when you either take half or you double. Since it's the angle that I know and I'm looking for the arc, I'm going to double the 62. So double the 62. $124. That is my arc measure here. 124 degrees. Now what I'm looking for is angle X, and angle X so happens to intercept the same arc, the 124. So I'm going to take the 124 and cut it in half, and that gives me 62. What you should recognize is that these two angles are equal. Why are they equal? Because they intercept the same arc. They're not in the same place, but they intercept the same arc. If you look at this like an ice cream cone, this is the top of your ice cream cone, and then I have a slanted green ice cream cone, and there's the top. They both share the same top, or the crust of a pizza. There's a slice of pizza, there's your crust. There's a wonky slice of pizza, there's your crust. They both share the same crust, so they both have the same angle measure, which is 62. All right, number 12 has a few pieces in there. Given circle C with the diameter of AR and the measure of angle HCA is 50 degrees. Okay, that's given. This is 50 degrees. All right, what is the measure of angle HIA? HIA. Okay, HIA is here. And that angle is an inscribed angle, and it intercepts this arc, which happens to be the same arc that this 50 central angle intercepts. So since that is a central angle, this is 50 because central angles equal their intercepted arcs. Now, the one I'm looking for is down here, and this is an angle, and it's not a central angle, it's inscribed, which means I'm going to cut the 50 in half. Put a little arrow there. Half of 50 is 25. All right, first piece down. The measure of angle HCR. Okay, I'm looking for this angle right in here, and HCR, I know it's going to get messy. I don't need to bubble in that outside piece. I'm going to, just in case, nope, I don't need it later. So there was no need to do this because I was looking for the angle, not the arc. All right. So I'm looking for angle HCR. This is a diameter, which means it's a straight line, which means whatever that angle is, plus 50 is going to equal 180. I'll just put a little X there. X plus 50 equals 180. Subtract X equals 130. And that should not be a 50. It was a, sorry, I made that 50 into an 80. That should be a 50. X plus 50 equals 180. Subtract the 50, you get 130. So this angle here is 130. Okay, HIR. Where is HIR? HIR is this angle right here. Now, HIR does intercept that arc that I started to mark earlier, so I'm going to put it in pencil now. Can you see that pizza slice? So this angle in here is not central. That there is a central angle. This is inscribed. It intercepts this arc, so I need to know the measure of that arc. Like we did previously, can you see where this green is? That green central angle intercepts the same arc, so if X is 130, this angle out here is also 130. Which makes sense, because that's a semicircle. 130 and 50 makes 180. 130 and 50 make 180. Okay, so angle HIR. HIR is this little angle down here, which is not a central angle, so it's not equal. It's an inscribed, and if I know the arc and I'm looking for the angle, I'm going to cut the arc in half. Half of 130. So 65. Okay, the measure of angle AIR. AIR. AIR is here, and we've done one of these before. AIR, can you see it here where it intercepts? I'll put it in red. It is an inscribed angle, and it intercepts a semicircle. So those two angles together is 180, and then you take half of 180, and that gives you 90. So this is a right angle. All right. Okay, let's flip over to the back. And I'm going to start with number 14. Okay. What is a degree measure of the arcs? Okay, if that's 52, I'm just going to label what I know. I know this is 52. I know this is a straight line. So I do 180 minus 52 and get 128. Vertical angles are congruent, 128. So what's the measure of arc DB? Arc DB is here, and it's going to equal its central angle, 128. And arc DCB, DCB. So it's a few angles, arcs together, D to C, all the way over to B. Two ways of doing this, and I've talked about it before. You can add three angles together, 52 plus 52 plus 128. Plug that in your calculator. 52 plus 52 plus 128 equals 232. Or some people might say, well, all the way around is 360, and the only one I'm not counting is the 128, so 360 take away 128 comes out to be the exact same thing, 232. So either way, it's up to you. Okay, number 17. I'm looking for angle T. And what do I know about angle T? It's half of this arc here, because angle T is an inscribed angle. It's half of the pizza crust. Okay, but I don't know the pizza crust, so how do I find the angle? Well, I'm going to call it for now X. And I know all the way around the circle is 360, so 130 plus 110 plus X equals 360. So 240 plus X equals 360. Subtract, and you get 120 degrees. So we now know this arc is 120. Now be careful, that doesn't mean that angle T is 120, because this is not a central angle, it's inscribed, and central angles are equal to half of the arc. So half of 120 is 60. Okay, number 19. In circle A, angle CDB is an inscribed angle. What is the measure of angle CDA? Okay, this is a combination of what we learned today plus what we learned the day before. All right, so let's mark what's given. CBD is an inscribed angle, which means this arc is going to be twice as big as that angle. So do 2 times 36 and you get 72. All right, now I'm going to turn it this way. What I'm looking for is the measure of angle CDA. Where is the measure of angle CDA? CDA. I'm looking for that angle there. Now, we talked yesterday about knowing that this is an isosceles triangle, because that's a radius and that's a radius. Radii are equal, or congruent, so I'm going to put my little tick marks there. If those two sides are congruent, that means this is a isosceles triangle. All right, now another thing you need to know is that this angle right here, since this is a central angle, angle A right there is equal to 72 degrees. Because central angles are congruent to their arcs, and inscribed angles are half. Half of 72 is 36, equal to 72 is 72. These two are equal. That is not equal, it's half of the 72. All right, so now I'm going to come up with my equation. I'll just put little x's there. And I know they're both x because they are congruent. So my equation is going to be x plus that little angle right there, which is 72, equals 180, because it's the inside measure of the inside angles of a triangle. The sum of the interior angles of any triangle is 180. So 2x plus 72 equals 180. And you're going to subtract 72 from both sides. 2x equals 108, and then you're going to divide both sides by 2. X equals 54. So the measure of angle CDA, which is right here, which is X, is 54. Okay. I'm going to do 20, 21. You can do 22 on your own. This is review from our previous unit, factor and solve. Okay, in order to do this, I need a 2 equals 0. X squared plus 2x minus 35 equals 0. Now I said factor and solve. Sometimes if you didn't want to factor, you could complete the square. You could use a quadratic formula, any one of those methods. I like to factor first, so I'm going to see if it does factor. X into X, my last sign's negative, so one's positive, one's negative. I list my factors of 35, 1 and 35, 5 and 7, and it looks like 5 and 7 is going to be what works. Now if it didn't factor, or if you don't like factoring, you could complete the square by leaving the 35 where it's at, putting plus blanks on each side, cutting in half and squaring, and blah, 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 blah. Or quadratic formula, your choice. Okay, I'm going to make the 7 positive and the 5 negative, so when I do my inside-outside, I get positive 2 in the middle. Since it equals 0, I'm going to solve. And we did this, not our previous unit, but the unit before, I believe is where we first started this. And we did it again last unit. X equals negative 7 and positive 5. No ordered pair, so no parentheses. These are two separate X values. Subtract 7 gives you the negative 7. Add your 5 gives you the positive 5. Now this one, and I've told you this before, this is the one where you're not going to factor or do anything special. This is the one where you're going to square root both sides. Square root, square root. Square roots and squares undo. Whenever you square root, you plus or minus. The square root of 16 is 4, and you plus or minus when you square root both sides of an equation. Plus 1 plus 1. X equals 1 plus or minus 4. X equals 1 plus 4, 1 minus 4. 1 plus 4 is 5. 1 minus 4 is negative 3, and you do not put parentheses because it is not an ordered pair. All right, that is it for this section of homework questions.